All right, let's talk about coding. If you've ever thought it's this super complex, secret language only geniuses can understand, well, I'm here to tell you that's just not true. And today, we're going to prove it. We're diving into Python, which is honestly one of the best and most powerful languages to get started with. So, let's jump right in.
So here's our game plan. We're breaking this down into 5 parts. First, we're going to cover the logic before the code. That's the real key. Then we'll get into why everyone, and I mean everyone, seems to love Python. After that, we'll get your workspace set up, cover the basic grammar, the nuts and bolts, and finally, we'll get our code to actually start thinking for itself.
Okay, Section 1, Logic Before Code. This is so important. Before you even think about typing a single command in Python, or really any language, you've got to get this one thing down. How to think like a programmer. It's not about memorizing a bunch of weird words, it's all about breaking down a problem into super simple logical steps. Steps so clear that a computer, which has zero imagination, can't possibly mess it up.
So that brings up the big question, right? How do you tell a computer exactly what to do? I love this analogy. A computer is like a super powerful genie. It can do incredible things, but it's also completely literal. It has no common sense, no imagination. It won't guess what you meant to say. You have to spell out every single step in the perfect order. And getting that right, that's the foundation of everything we're about to do.
And that perfectly leads us to this word you've probably heard a million times: algorithm. It sounds kind of fancy and technical, right? But honestly, don't let the name intimidate you. An algorithm is just a plan. That's it. It's the recipe, the step-by-step instructions you create to solve one specific problem, from start to finish.
The best way to think about it is a recipe for baking a cake. Seriously, the recipe is your algorithm. If you follow the steps in the right order, you mix the batter, then you bake it, then you frost it, you get a delicious cake. But what happens if you try to frost the liquid batter before you put it in the oven? You get a sloppy, inedible mess, right? Well, programming is exactly like that. The order and the clarity of your steps mean everything.
Okay, so how do programmers actually map out these steps? Well, a lot of the time, they use something called a flowchart. You can just think of it as a blueprint for your code. It's a way to draw out the whole process, see how everything connects, and spot any problems or dead ends before you've even written a single line of code. It's like having a superpower for planning.
All right, so we've got the whole planning part down. We know we need a logical recipe. Now we need the right tool to actually cook with it. And for us, that tool is going to be Python.
So why Python? What's the big deal? Well, for starters, its syntax, the grammar of the language, is super clean. It almost reads like plain English, which is a huge deal when you're just starting out. Then there's its massive library of built-in functions. Think of it like a giant toolbox full of pre-made tools, so you don't have to build everything from scratch. And finally, the thing is just so versatile. We're talking about the language that helps run Instagram, that NASA uses for data analysis, and it's an absolute beast in the world of AI. It's the real deal.
Okay, so we've got our logic, we've got our language, now we need a place to work. Let's talk about setting up your coding workspace.
So to actually write and run Python, you really only need 2 things. First is the interpreter. That's the piece of software that translates your Python code, which you can read, into machine code that the computer can actually understand and execute. The second thing is an IDE, an integrated development environment. Don't worry about the long name, it's basically just a special text editor built for writing code. And the great news is, when you download Python, it comes with a basic one called idle right in the box, so you're ready to go. Now, once you open up idle, you'll see you can work in 2 main ways. On the one hand, you've got interactive mode. This is like a command line or a direct chat with Python. You type one line of code, hit enter, and boom, you get an answer right away. It's awesome for quick tests. On the other hand, you have script mode. This is where you write a whole program, a full script in a file, and then you run the whole thing at once. This is how you build actual applications.
Okay, now we get to the really good stuff, learning to actually speak the language of Python. And just like learning Spanish or French, it has its own grammar and vocabulary. So let's dive into the essential building blocks you're going to use every single day.
The first and maybe the most important concept to grasp is the variable. The easiest way to think about it is just as a labeled box. It's a container in the computer's memory that you give a name to, and then you can store stuff inside it. A number, a piece of text, whatever. Later on, you just use the name on the box to get your data back. It's that simple.
Now you can't just name these boxes anything you want. There are a few rules, kind of like naming a file. First, the name has to start with a letter or an underscore. No numbers at the beginning.
Also, you can only use letters, numbers, and underscores. No weird symbols like exclamation points or dollar signs. And this one gets everybody at first. Variable names are case sensitive. That means a variable named age in all lowercase is completely different from one named age with a capital A. You got to watch out for that.
So what kind of stuff can we actually put in these variables? Well, Python handles a few main types of data. You've got numbers, which can be whole numbers, integers, or numbers of decimal points, which are called floats. You have text, which in the programming world we always call strings. You can have sequences, which are basically collections of items like a list. And finally, you have Booleans, which sounds complicated, but it's literally just the value true or the value false.
And of course, once we have data, we want to do stuff with it. Python can function just like a calculator. You've got all the basic math operators you'd expect: addition, subtraction, multiplication, division. Here's a cool one to remember. 2 asterisks in a row means to the power of. So if you write 3 asterisk asterisk 2, that's Python's way of saying 3 squared, which of course is 9.
Okay, but besides doing math, we also need to ask questions. And for that, we use comparison operators. These are things like greater than or less than. The key thing here is they don't give you a number back. They give you a Boolean, a true or a false. So you can ask, is 20 greater than 10? And Python will answer true. Now look closely at the equal to operator. It's a double equal sign. This is absolutely critical. A single equal sign puts a value into a variable. A double equal sign asks if 2 things are already equal. Mixing those 2 up is a classic mistake, so really burn that one into your brain.
All right, which brings us to our final section, making your code think. We've got the basic vocabulary down. Now it's time to learn how to form sentences, how to create logic that lets our programs make decisions, and handle more than just one piece of data at a time.
So how does a program actually make a choice? It all comes down to the if statement. This is your core decision-making tool. You start with if, followed by a question that results in true or false. If the answer is true, the code indented right underneath it gets executed. And that indentation is super important in Python. It's not just for looks, it's how Python knows what code belongs to the if. Now, if the condition is false, the program just skips that indented block entirely and looks for an else statement. If it finds one, it runs the code under that instead. It's a fork in the road for your code.
But what about when you need to do something over and over again? I mean, you're not going to copy and paste the same line of code 100 times, right? That's what loops are for. And the most common one is the for loop. The best way to picture it is like a little robot on an assembly line. You give it a collection of items, and it goes through them one by one, doing the exact same task on each item until it gets to the end of the line.
And when we talk about a collection of items for a loop to work on, most of the time you'll be using a list. A list is probably one of the most useful things in all of Python. It's just what it sounds like, a list of items. You create it with square brackets, and you can put whatever you want in there. Numbers, strings, you can even mix and match. They're incredibly flexible, and you'll be using them all the time.
And actually using lists is pretty simple. To grab an item from a list, you just need to know its position, which we call its index. But here it is again, one of the most important rules in programming, so listen up. Indexing starts at 0, not 1, 0. So the very first item in a list is at index 0, the second is at index 1, and so on. Once you get that burned into your brain, the rest is easy. You can add new items to the end with a command called .append, or remove items with .remove.
So when you take all these little pieces we've talked about, the variables that hold your data, the operators that let you do math and ask questions, and the control flow like if statements and for loops that let your code make decisions, when you put all of that together, what you have is a computer program. And that's really all it is. It's not some kind of dark magic. It's just a set of instructions carefully laid out to get a specific job done.
So, there you have it. We've just gone over the absolute fundamentals, the logic, the tools, and the basic grammar of Python. These are the building blocks. You now literally have what you need to start putting them together and creating something from scratch. So the real question isn't, can you code? It's, what do you